Hello, in this video, I will take you through how I use machine learning and AI to help me with my problem of forgetting medications. Me and my wife both are diabetic, which we were controlling in all possible ways, but were forgetting medications. I had to take my pills with breakfast, and that is what I was missing often. We tried alarms, but as morning chores were difficult to time, alarm became more of a disturbance than being of much help. Our doctors were not happy, and we kept postponing our refills. Hi, my name is Rupam Roy. I'm a web architect and recently a technical enthusiast for machine learning and AI, gaining knowledge on various machine learning libraries and technologies like TensorFlow, Keras, OpenCV, etc. In this story, I'll explain how I used my knowledge to solve this problem of forgetting medications, and in that process, put my learnings into actual practice. We'll also see a demo of the system. I hope you like it. Last summer, when my mom was here, she used to remind us for taking our medications when she used to see us taking breakfast. After she went back to India, we were back to square one. That was the inspiration behind my idea of creating an AI computer vision system, which, when will see us taking breakfast, will immediately check with us about our medications. For hardware, I chose a cheap varifocal lens USB camera, a 4 GB Raspberry Pi, and a connected set of speakers. For software, I initially thought of using readily available object detection models through various Python libraries like TensorFlow, OpenCV, etc. My initial plan was to detect my dining table, detect persons around it, and if the person is very close to the table, then ask through the computer speaker if the medications were taken. But this was not that easy. In reality, we may be close to the table, but doing something else and not eating. And then there are my kids and guests who do not need a medication check. So I realized that I need to use my own CNN. CNN stands for Convolutional Neural Network, which is a mathematical algorithm used widely in computer vision. We will talk about the technical details later, but let's now see a demo of the system in action, which I recorded one Friday morning during breakfast. Hi guys, prime time. We are now going to see a demo of this home medication checker computer vision system that I have built. This is my morning room and my living area, and here I have my camera on the shelf, placed nice and neat, and then there are two speakers uh, which announces the medication check as soon as the camera sees me eating my breakfast. So I'm gonna slowly turn this phone towards my dining table. And you can now see that my kid is having breakfast. So far, no alarms have been triggered. It's morning breakfast time, and I'm going to go and get my breakfast. And we'll see, you'll be hearing a medication check when I start eating. Here I have my breakfast ready. The camera is going to take pictures a few seconds.
Good morning. Looks like you are having your breakfast. Did you take your medicines?
Weather headlines for this week. Mostly cloudy this weekend. Today's max temperature would be 69.0 and min would be 47.0. Daytime mostly sunny with no precipitation and nighttime intermittent clouds with no precipitation. Rain is not expected in the next 12 hours.
So there you go, guys. You could see as soon as I sat and start eating my breakfast, it it um, it did check if I have taken a breakfast or not. Thanks for watching. Thank you, everyone.
I hope you liked the demo. You saw that I also had it tell the weather by programming in a weather feed. At breakfast, weather information is quite useful to plan the day. I also plan to put in the morning headlines and maybe traffic information at a later point of time. Now let's get a bit technical and see how the system was built. As I was saying earlier, I had to program a CNN. Explaining in an extremely simple manner, a CNN is like an equation which you take through a process called training, where you feed it the pixel values of hundreds and thousands of images labeled as eating or not eating. And in that process, it solves the equations, finding its weights and bias, or what we call the coefficients of the equation. Later, when you present it with a new image, it will use those coefficients to deduce if the image is eating or not eating. So, by now you can see that I needed to train the CNN, for which I had to collect a lot of images. I created a Python program for detecting persons near my dining table, and when that happened, it would send those images to AWS S3. Over a few months, I collected a lot of images. The next step was to label those thousands of images as eating and not eating. Now, Amazon has a service called AWS Mechanical Turk, which companies use to outsource labeling work to a global workforce. I had a different version where I bribed my kid to help me with that. He did a good job, but he was costly as he had extremely expensive remuneration. Good for him. I'm sure he will do extremely well in his salary negotiations in future. Once I had the labeling done, I used AWS SageMaker to train the CNN. I used what we call as transfer learning to create the model, and then a TF Lite converter to convert the model to a smaller size to fit the memory of mobile phones and IoT devices like Raspberry Pi. Once the model was loaded to Raspberry Pi, it was intelligent to do the process of intended inference, which was eating detection in this case. Let's look at how much it cost. Hardware was approximately $200 and training was $20 to $25. Current accuracy of the system, I can say, is around 85%. But I will be refining the hyperparameters and doing training with more diversified set of images to increase accuracy. I have a video of the same what we saw in the link below where I explain the technical details in much more greater detail. If anyone interested can take a look into the same. Thanks a lot for watching this. I hope you liked it.